this gentle journey through the universe's secrets, whispered softly to cradle you into deep, restful sleep. Imagine yourself right now in the present vastness of space, floating weightlessly among the stars, where every breath you take draws in the calm of the cosmos, gently, slowly easing away the day's tensions, gently, slowly allowing your mind to drift like a comet through the night sky. As we begin, let's focus on your breathing, inhaling deeply through your nose, feeling the cool, expansive air of the universe filling your lungs, holding it for a moment as if capturing a distant galaxy's light, then exhaling gently, slowly, releasing any lingering thoughts, gently, slowly letting go of everything that no longer serves you. Now settle into your comfortable position, whether lying down or reclining, and let this whisper guide you through a soothing body scan, starting from the top of your head, where the crown feels the subtle pull of gravity, like Earth's gentle tether to the sun in our current solar system, a bond that's held steady for billions of years. Feel that area relaxing, gently, slowly softening, as if melting into the infinite blackness of space, gently, slowly releasing any tightness from your scalp, your forehead smoothing out like the smooth curve of a planetary orbit observed today by telescopes like the James Webb, capturing the present dance of celestial bodies with unprecedented clarity. Moving downward to your eyes, those windows to the stars, allow them to close heavily, gently, slowly sinking into rest, gently, slowly blurring away the images of the day, recalling how in the past, ancient astronomers gazed at the same night sky with wonder, their observations laying the foundation for our modern understanding, and looking ahead to the future where advanced probes will reveal even more hidden worlds. Let your eyelids grow heavier, as if shielded from the bright flares of supernovae that light up the cosmos now, their energy echoing from eons ago. Next, your cheeks and jaw. Feel them loosening, gently, slowly unclenching, like the gradual release of cosmic dust settling into new formations. Gently, slowly allowing your face to relax completely, mirroring the serene equilibrium of galaxies in the present era, where clusters hold together through invisible forces discovered over past decades, and promising in the future to unveil mysteries of dark matter through ongoing missions. Your mouth softens, tongue resting peacefully as whispers of universal secrets flow around you. Now, shift your awareness to your neck and shoulders, those pillars carrying the weight of your world. Let them drop gently, slowly into profound ease. Gently, slowly shrugging off burdens like a planet shedding its atmosphere over geological time, connecting the current stability of our solar neighborhood, rooted in historical formations from the early universe to forthcoming explorations that will map uncharted territories. Feel the warmth spreading, dissolving any knots as if warmed by the sun's steady rays, observed in real time by satellites today, descending to your arms and hands, from shoulders to fingertips. Allow a wave of relaxation to wash over them, gently, slowly unfolding, like the arms of a spiral galaxy unfurling in the present cosmic web. Gently, slowly, letting fingers uncurl as if releasing stardust from ancient explosions that birthed elements long ago, anticipating future discoveries of habitable zones in distant systems. Your hands grow heavy, palms open to the void, inviting tranquility. Your chest and upper back now, expanding with each rising and falling in rhythm with the universe's pulse, gently, slowly releasing any held emotions, akin to the heartbeat of pulsars spinning in the now, echoes of stellar collapses from the distant past, and signals we might decode in tomorrow's observatories. Feel your heart rate slowing, steady and calm, moving to your abdomen and lower back. Let this core area soften, gently, slowly sinking deeper into your resting place. Gently, slowly, like the core of a star stabilizing in its current phase, built from primordial gases of yesteryears, destined for evolutionary changes in eons ahead. Allow your belly to rise and fall effortlessly, cradling you in comfort. Now, your hips and thighs, heavy and grounded, relax them gently, slowly dissolving tension as if merging with the dark energy pervading space today. Gently, slowly recalling the inflationary expansion from the universe's infancy and foreseeing its accelerating stretch into infinity. Feel the muscles unwinding, becoming limp and at peace, descending to your knees and calves. Let go of any lingering strain, gently, slowly straightening or bending as needed in repose, gently, slowly like the paths of asteroids orbiting in the present asteroid belt, remnants of planetary formation in antiquity, pathways that future spacecraft will navigate. Your legs grow heavier, anchored yet free. Finally, your feet and toes, from ankles to the tips, allow them to relax completely, gently, slowly spreading out like roots into the cosmic soil, gently, slowly releasing the last traces of the day, embodying the grounded now of our planet's place in the galaxy, tied to its historical journey around the Milky Way, and open to the endless possibilities of interstellar travel ahead. Your entire body now floats in this universal embrace, ready to delve deeper into the secrets that await. As your body drifts in this cosmic cradle, fully relaxed and open to the whispers of the universe, let us now turn our gentle gaze to the present marvels unveiled by the James Webb Space Telescope. That magnificent eye in the sky peering into the depths of space right now, capturing images of distant galaxies where stars are being born in vibrant nurseries of gas and dust, gently, slowly drawing us into their luminous embrace, gently, slowly revealing the ongoing dance of creation that shapes the cosmos we inhabit today. Imagine these galaxies as vast, swirling oceans of light scattered across the infinite expanse, where in the current era, Webb's infrared vision penetrates the veils of interstellar fog to show us clusters like those in the early universe's echoes, with over 5,000 such formations detected forming stars far sooner than once thought, their young stellar populations glowing with the fresh energy of hydrogen fusing into helium, a process observed in real time through Webb's precise instruments launched by NASA and ESA, allowing us to witness the universe's active evolution as it unfolds before our very eyes. In this present moment, as you breathe gently, slowly in and out, syncing with the rhythmic pulsations of these celestial bodies, gently, slowly letting your mind wander among them like a silent voyager. Consider how Webb has spotlighted galaxies such as Jadis GS Z13-1, a beacon from the dawn of time, yet active in clearing the primordial haze that once shrouded the cosmos, its intense ultraviolet light ionizing surrounding hydrogen gas to create transparent bubbles in space, a phenomenon captured in 2025, data that illustrates how these early giants are transforming opaque regions into clear vistas, enabling light from even farther realms to reach us now, painting a picture of a universe that's dynamically alive, with star formation rates in these distant realms rivaling those in our own Milky Way, all documented through Webb's near-infrared camera that filters the ancient glow into comprehensible spectra for scientists today, shifting our whisper to the echoes of the past as your relaxation deepens gently, slowly like the gradual cooling of cosmic embers, gently, slowly unraveling the threads of history woven into these observations. We delve into how these present images transport us back to mere hundreds of millions of years after the Big Bang, where Webb's discoveries in 2025, including the galaxy GHZ2 harboring the earliest known supermassive black hole, just 570 million years post-Big Bang, reveal the chaotic infancy of galaxy formation, a time when gravity first pulled together vast clouds of primordial gas into clumpy, messy structures that struggled to settle into the orderly spirals and ellipticals we see later, with data showing these proto-galaxies birthing stars at frantic paces amid turbulent mergers, their black holes growing greedily by devouring surrounding matter, as evidenced by the rapid accretion observed in spectra from the telescope's mid-infrared instrument, painting a vivid portrait of a youthful universe bursting with raw potential and violent energy that laid the foundations for everything that followed. These historical insights, drawn from light that has traveled billions of years to reach us now, allow us to gently, slowly piece together the narrative of cosmic adolescence, gently, slowly appreciating how in that distant past, galaxies like the newly identified Alaknanda, a surprisingly mature grand design spiral emerging only 1.5 billion years after the universe's birth, challenged our models by displaying organized arms and bars far earlier than predicted, their formation driven by density waves rippling through gas disks, as uncovered in recent Webb analyses that highlight the role of dark matter halos in sculpting these early behemoths, reminding us of the intricate ballet of forces that began shaping the cosmic web long ago, with supernovae explosions seeding heavier elements into the void, elements that would one day form planets and life in later epochs. Now, as we float forward in our minds to the future horizons, gently, slowly anticipating the next chapters in this grand story, gently, slowly envisioning the advancements that await, we can foresee how ongoing and upcoming missions will build upon Webb's legacy, with ESA's Euclid telescope already complementing by mapping billions of galaxies in 3 dimensions to trace their evolution further, and NASA's planned Roman Space Telescope set to launch in the coming years to survey even wider fields with greater speed, promising to uncover tens of thousands more early galaxies and refine our understanding of their star formation histories, potentially revealing hidden populations of faint, low-mass systems that elude current detection, all while probing the mysteries of dark energy that accelerates the universe's expansion, leading to a time when these whispers of discovery will illuminate the ultimate fate of the cosmos in unprecedented detail. In this tapestry of time, where present observations bridge the ancient past to the unfolding future, feel your thoughts gently, slowly dissolving into the vastness, gently, slowly carried away on waves of cosmic light, as Webb continues to whisper secrets of galaxies forming anew, their stories a lullaby for your deepening slumber, inviting you to rest in the knowledge that the universe's wonders are eternal, ever evolving in their quiet majesty. As your slumber deepens amidst these eternal wonders, with galaxies' lullabies fading into the background like distant echoes in the void, let us now immerse ourselves in the present rhythm of the universe's expansion, that subtle yet profound stretching of space itself, measured with exquisite precision by telescopes like the venerable Hubble and the innovative Euclid, gently, slowly pulling everything farther apart in this ongoing cosmic ballet, gently, slowly inviting us to contemplate the vast scales where galaxies recede from one another, not through motion, but through the fabric of space-time elongating, as revealed in contemporary observations that capture the redshift of light from far-off sources, a phenomenon where wavelengths stretch longer, turning blue to red as they journey across billions of light years to our detectors today. In this current epoch, as you allow your breath to flow gently, slowly in harmony with this expansive pulse, gently, slowly feeling your own form relax even further into the embrace of night, envision how the Hubble Space Telescope, orbiting Earth since the 1990s but continually upgraded, has provided foundational data on this expansion rate, known as the Hubble constant, with recent analyses in 2025 integrating inputs from its wide-field camera 3 to affirm values around 73 kilometers per second per megaparsec, meaning that for every million parsecs of distance, about 3 million light years, galaxies appear to move away faster by that speed, a figure corroborated by ESA's Euclid mission, which in its early 2025 data releases from wide-field surveys of over 1 million galaxies, has independently confirmed this rate at precisely 73 kilometers per second per megaparsec, higher than some earlier cosmological models predicted from microwave background radiation, thus highlighting the ongoing Hubble tension where local measurements diverge from those inferred from the universe's infancy, all while Euclid's visible and near-infrared imagers map the shapes and positions of these galaxies to trace how dark energy influences this acceleration in the here and now. These present-day insights, woven from light that has traversed the cosmos to reach us, allow us to gently, slowly appreciate the dynamic nature of our universe today. Gently, slowly, like a vast ocean tide, drawing shores apart imperceptibly yet inexorably, where Euclid's observations of weak gravitational lensing, subtle distortions in galaxy images caused by intervening mass, further quantify how this expansion accelerates, with dark energy comprising about 68% of the universe's total content, as per integrated NASA and ESA datasets, driving galaxies to separate at ever-increasing speeds, a reality captured in Euclid's first science images from 2025 that showcase clusters like Abel 2390, where the bending of light around massive structures reveals the invisible scaffolding of dark matter holding things together amid the pool, offering a snapshot of the cosmos in its mature phase, balanced yet ever-shifting under these fundamental forces, turning our whisper back to the echoes of the past as your mind drifts gently, slowly through layers of time like light-piercing ancient dust clouds, gently, slowly unraveling the origins of this grand expansion. We connect these a second during the inflationary epoch, setting the stage for the steady expansion we observe now, with Hubble's early discoveries in the 1920s first hinting at this through the recession of galaxies, and subsequent refinements showing how in the aftermath, radiation dominated the young universe, cooling as space stretched, allowing matter to clump into the first stars and galaxies, a history etched in the cosmic microwave background radiation that Planck's satellite mapped with precision, revealing tiny fluctuations from quantum scales amplified by inflation, which Euclid's 2025 data builds upon by linking those primordial seeds to the large-scale structures we see today, illustrating how the initial burst transitioned into the decelerating phase, driven by gravity before dark energy took over around 5 billion years ago, reshaping the cosmic narrative from contraction's pull to eternal divergence. These historical threads, illuminated by the red-shifted glow arriving from eons past, help us gently, slowly comprehend the foundational mechanics that birthed our reality. Gently, slowly, like roots of a cosmic tree, delving deep into fertile soil of possibility, where the Big Bang's energy release not only spawned particles and forces, but also imprinted the expansion rate that evolved over time, with early universe models from ESA's 2025 analyses, suggesting an initial Hubble parameter far higher. Decreasing as matter density waned, a evolution tracked through supernova observations that Hubble pioneered, showing how type Ia explosions served as standard candles to gauge distances and speeds across cosmic history, tying the violent births of the past to the measured calm of the present, now gazing ahead to the future vistas as relaxation envelops you gently, slowly like a blanket of stars unfolding across the night, gently, slowly foreseeing the paths yet to be charted. We can anticipate how this expansion will lead to a colder, more isolated universe, where dark energy's dominance causes acceleration to continue unchecked, diluting matter and radiation until galaxies beyond our local group become invisible, their light redshifted into oblivion over trillions of years, culminating in a heat-death scenario as predicted by thermodynamic models informed by Euclid's projections, with stars exhausting fuel, black holes evaporating through Hawking radiation, and the cosmos reaching a state of maximum entropy, eternally expansive yet profoundly empty. A fate that ongoing missions like NASA's Roman telescope will refine through deeper surveys, whispering hints of alternative outcomes if new physics emerges, yet for now painting a serene, inevitable chill where all activity fades into uniform quietude. In this continuum from vibrant present to storied past and distant future, let the universe's expansion carry your thoughts gently, slowly into deeper peace, gently, slowly expanding your own inner space toward profound, restful sleep. As these secrets continue to unfold in whispered harmony, as these expansive secrets lull you further into tranquility, with the universe's stretch mirroring the easing of your every muscle, let us now envelop ourselves in the present enigma of dark matter, that invisible scaffold holding galaxies in their graceful spin, unveiled through the meticulous observations of ESA's Gaia mission, gently, slowly weaving a three-dimensional tapestry of over 2 billion stars in our Milky Way, gently, slowly tracing their positions and velocities to reveal the subtle gravitational tugs that betray this hidden presence, as captured in the mission's final data releases from 2025, where the precise astrometry maps the stellar streams and dispersions influenced by an unseen mass permeating the galactic halo. A reality affirmed by the satellite's decade-long survey that concluded its observations earlier this year, offering astronomers a dynamic portrait of how ordinary stars orbit faster than visible matter alone could dictate, their paths curving under the influence of this elusive component that comprises about 27% of the universe's total content, all documented through Gaia's billion-pixel camera that has charted the proper motions and parallaxes with unprecedented accuracy, illuminating the dark matter's role in stabilizing the galactic disk we call home today. In this contemporary vista, as your eyelids grow heavier, gently, slowly sinking with the steady rhythm of these stellar dances, gently, slowly allowing your awareness to float amid the mapped constellations, picture how Gaia's 2025 analyses, including studies by researchers like Alain Blanchard and Yves Coquerel, have utilized the velocity data of millions of stars to reconstruct the Milky Way's rotation curve. That plot of orbital speeds versus distance from the center, showing a remarkably flat profile where speeds remain constant, far beyond where they should drop, if only baryonic matter, stars, gas, and dust were at play. A finding that robustly supports the existence of a dark matter halo enveloping our galaxy, with the 3D map of 2 billion stars providing the positional backbone to model this invisible density distribution, extending up to hundreds of thousands of light years, and inferred from the way stellar populations in the halo exhibit velocity dispersions too high for visible gravity alone, as detailed in recent papers that compare these observations against alternative theories, ultimately favoring dark matter's cold, collisionless particles clustering in halos, as described by the Navarro-Frank-White profile, all drawn from Gaia's astrometric precision that resolves motions down to micro arcseconds per year, painting a live snapshot of the cosmos where this shadowy essence counterbalances the centrifugal forces threatening to fling stars into the void. These ongoing revelations, etched in the light paths arriving from our galactic neighbors, invite us to gently, slowly embrace the unseen architecture sustaining the present harmony, gently, slowly, like a cosmic veil draping over familiar skies, where Gaia's data on gravitational microlensing events, subtle deflections in starlight caused by foreground masses, further hints at compact dark matter objects, with 2025 updates cataloging dozens of such occurrences that probe potential candidates like primordial black holes or massive compact halo objects, though the bulk evidence points to a diffuse particle sea, integrating seamlessly with the mission's broader senses that has refined our understanding of the local dark matter density to about 0.4 solar masses per cubic parsec near Earth, a value honed through kinematic analyses of K-dwarf stars whose vertical oscillations above the galactic plane whisper of the underlying gravitational well, drifting backward to the whispers of yesteryear as serenity washes over you gently, slowly unraveling the origins of this profound mystery, gently, slowly retracing the steps of discovery that echo through decades. We recall how dark matter first emerged in the 1930s through Fritz Zwicky's observations of the Coma Cluster, where galaxies moved too swiftly for their visible mass. But it was in the 1970s that Vera Rubin's meticulous measurements of spiral galaxy rotation curves, using optical spectra to regions orbited at speeds matching the inner ones, defying Newtonian expectations and implying an invisible mass extending far beyond the luminous disks. A breakthrough built on earlier hints from radio astronomy that mapped neutral hydrogen emissions, leading to the lambda-cold dark matter model that posits weakly interacting massive particles formed in the early universe's hot plasma, cooling to clump under gravity and seed galaxy formation. All foundational insights that Gaia's modern data refines by applying similar principles to our own Milky Way's intricate stellar dynamics. These archival echoes, preserved in the red-shifted signals from distant epochs, help us gently, slowly appreciate the evolutionary tapestry that birthed this cosmic phantom. Gently, slowly, like ancient roots nourishing the tree of knowledge, where the past's rotational anomalies in hundreds of galaxies, cataloged through surveys like those of the 21-centimeter line, underscored dark matter's dominance over ordinary matter by a factor of 5, influencing everything from large-scale structure formation after the Big Bang to the stability of galactic bars and arms observed in historical plates, setting the stage for today's orbital tracings that confirm its pervasive grip. Now peering into the horizons yet to dawn, as peace enfolds you gently, slowly, like the gradual unveiling of new constellations. Gently, slowly envisioning the quests ahead, we anticipate how future particle colliders, such as the High Luminosity Large Hadron Collider at CERN, slated for operations ramping up in 2029, will seek to produce and detect dark matter particles directly, smashing protons at energies up to 14 tera-electron volts to potentially create weakly interacting massive particles or axions in controlled collisions. With detectors like ATLAS and CMS sifting through trillions of events for missing energy signatures where dark matter escapes unseen, complemented by underground experiments like those at Gran Sasso or Snow Lab that hunt for rare interactions with atomic nuclei, promising to identify the particle nature of this enigma and bridge astrophysical observations with quantum realms. While next-generation space telescopes build on Gaia's legacy to map dark matter in distant clusters through weak gravitational lensing, distorting background galaxy images to trace its web across cosmic time, ultimately unraveling whether it's primordial black holes, sterile neutrinos, or something unforeseen, guiding us toward a unified theory in the eons to come. In this seamless flow from tangible present to foundational past and exploratory future, let dark matter's subtle embrace carry your consciousness gently, slowly toward oblivion's edge, gently, slowly dissolving into the night's infinite depths as the universe's veiled truths continue their soft revelation. As these veiled truths continue their soft revelation, drawing you deeper into the cosmic hush where shadows and light intertwine in eternal balance, let us now surrender to the present embrace of dark energy, that mysterious force propelling the universe's accelerating expansion. Illuminated through the vigilant eyes of NASA's Dark Energy Survey and its supernova observations, gently, slowly infusing the vastness with an unseen push that stretches space ever outward, gently, slowly manifesting in the dimming glow of distant exploding stars, whose light reaches us today as a testament to this elusive power, as captured in the 2025 reanalysis of the DES 5-year supernova sample, where over 1,000 type E supernovae, those reliable cosmic beacons born science in driving galaxies apart at increasing speeds, a phenomenon quantified without intricate equations, but through the simple comparison of distance and velocity. With the survey's updated calibration, incorporating improved light curve models to affirm that this energy constitutes approximately 68% of the universe's total makeup, all drawn from the collaborative efforts of NASA and international partners who have refined these measurements to unprecedented precision in the current era. In this unfolding now, as your breath aligns gently, slowly, with the subtle swell of this expansive force, gently, slowly letting your essence expand into the infinite like ripples across a cosmic pond. Envision how the Dark Energy Spectroscopic Instrument, or DESI, complements these findings with its 2025 data releases from mapping millions of galaxies via baryon acoustic oscillations, those ancient sound waves frozen in the distribution of matter, further solidifying dark energy's role by tracing how its influence has accelerated the cosmic recession since the universe's midway point. With combined datasets from DES supernovae and DESI's spectroscopic redshifts indicating a current equation of state parameter near -1, where values slightly above or below hint at its nature, whether constant or subtly shifting, as recent analyses suggest a weak preference for evolution over time, potentially weakening rather than remaining steadfast, all observed through the Lawrence Berkeley National Laboratory's instruments that scan the night sky to capture these signals in real time, offering a portrait of a universe where dark energy counteracts gravity's pull, preventing collapse and instead fostering an ever-widening solitude among celestial islands. These contemporary whispers, carried on photons from cataclysmic events light years away, allow us to gently, slowly immerse in the active symphony of repulsion that defines our epoch. Gently, slowly, like an invisible wind filling the sails of distant voyagers, where the 2025 updates from the DES Supernova program, including recalibrations based on white dwarf spectra and enhanced photometric accuracy, have tightened constraints to show dark energy's imprint on the Hubble diagram. That plot of supernova brightness versus redshift, demonstrating acceleration beginning around 5 billion years ago, a shift that aligns with broader cosmological probes and underscores its quantum vacuum origins or field-like behavior, pervading every cubic centimeter of space with a density that remains uniform even as volumes grow, a reality that NASA's ongoing missions continue to probe through ever larger catalogs of these stellar explosions, each one a fleeting flash echoing the force's pervasive hold, venturing back to the annals of cosmic history as tranquility envelops you gently, slowly unraveling the genesis of this enigmatic component, gently, slowly tracing its roots through the lambda-cold dark matter model that has framed our understanding since the late 1990s. We connect these present observations to the foundational framework where dark energy enters as the cosmological constant. Lambda, introduced by Einstein in 1917, but repurposed after the 1998 supernova discoveries by teams like the High Z Supernova Search and Supernova Cosmology Project, which first detected the unexpected speed-up through Type Ia events at redshifts around 1, revealing a universe not destined for recollapse, but eternal dilation, with the model integrating cold, dark matter's clumping for structure formation alongside ordinary matter and radiation, all evolving from the Big Bang Planck's hot dense state, where quantum fluctuations seeded the inhomogeneities we see. As refined by cosmic microwave background maps from Planck that pinned dark energy's fraction near 68% in early formulations, a paradigm that DES and DESI data in 2025 build upon. By testing extensions where the equation of state might deviate from -1, echoing the past's theoretical battles between steady state and expanding models that ultimately favored this lambda-inclusive vision. These echoes from antiquity, preserved in the stretched wavelengths arriving across eons, enable us to gently, slowly honor the evolutionary path that embedded dark energy within the cosmic equation. Gently, slowly, like ancient currents shaping the riverbed of reality, where the model's success in explaining galaxy clustering, light element abundances, and the flat geometry observed through angular diameter distances underscores its robustness, yet invites scrutiny as 2025 analyses hint at tensions that may require refinements, bridging the theoretical constructs of the past with the empirical validations of today. Now casting our gaze to the tomorrows yet unwritten, as repose claims you gently, slowly, like the gradual dimming of twilight stars, gently, slowly foretelling the destinies inscribed in this force's trajectory. We contemplate how if dark energy persists as a constant, the universe drifts toward heat death in trillions of years. But if it embodies phantom qualities with an equation of state less than -1, as some models posit, and strengthens over time, it could culminate in the Big Rip, a scenario where acceleration tears apart galaxies, solar systems, planets, and even atoms in a finite future, perhaps 22 billion years hence, with structures unbound as the scale factor diverges to infinity. Though recent 2025 DESI and DES hints of a weakening evolution suggest alternative fates where expansion might plateau or reverse under modified gravity, prompting future telescopes like the Nancy Grace Roman to survey billions more supernovae for clearer prophecies, unraveling whether dissolution or equilibrium awaits in the vast expanse ahead. In this timeless weave of energizing present, modeled past, and speculative future, permit dark energy's gentle surge to ferry your awareness gently, slowly into slumber's abyss, gently, slowly where all queries dissolve in the universe's quiet expanse. As this quiet expanse cradles your drifting thoughts, where dark energy's subtle currents fade into the profound silence of space, let us now descend into the present allure of black holes, those enigmatic voids captured in stunning detail by the Event Horizon Telescope, a global array of radio dishes sinking to form an Earth-sized virtual eye that peers into the hearts of galaxies, gently, slowly unveiling the shadowed horizons, where light itself succumbs to gravity's inexorable grasp, gently, slowly highlighting the supermassive black hole at our Milky Way's center, Sagittarius A, with 2025 images boasting enhanced resolution that expose spiraling magnetic fields encircling its event horizon like ethereal rings of force, as revealed in collaborative NASA and ESA analyses, where polarized light observations trace these fields' twisted structures, channeling plasma jets outward and regulating the accretion of infalling matter, a phenomenon documented through the telescope's upgraded baselines, incorporating new Antarctic stations for sharper view. These observations affirm general relativity's predictions under extreme conditions, with the magnetic field's strength estimated to influence the black hole's feeding rate, sporadically devouring gas clouds that venture too close, as evidenced by the variability in brightness captured over multiple observing campaigns. In this immediate cosmic theater, as your relaxation deepens gently, slowly attuning to the gravitational symphony of these behemoths, gently, slowly envisioning the photon rings glow as a beacon in the void, consider how the Event Horizon Telescope's 2025 data on Sagittarius A, building on initial 2022 portraits, now resolves finer details of the magnetic topology, with polarization maps showing helical patterns that suggest ordered fields threading through the accretion disk, a discovery that elucidates how these fields launch powerful outflows observed by NASA's Chandra X-ray Observatory in tandem, preventing overfeeding and maintaining the black hole's relatively quiescent state compared to more active counterparts, with the image's improved angular resolution down to 15 micro-arcseconds, revealing asymmetries in the ring that hint at the black hole's spin tilting at about 30 degrees to our line of sight, all integrated from petabytes of data processed through advanced correlation techniques, offering a real-time glimpse into the dynamics where gravity warps space-time so profoundly that escape velocity exceeds light speed, embodying the universe's most efficient engines for converting matter into energy via frictional heating in the surrounding plasma, a process that lights up the galactic core we study today. These vivid portrayals, forged from radio waves collected across continents and synchronized to atomic clocks, invite us to gently, slowly marvel at the inescapable pull defining our galactic hub, gently, slowly, like an unseen anchor steadying the stellar whirl, where the 2025 enhancements, including contributions from ESA's Atacama Pathfinder experiment, have mapped the magnetic field's flux density to levels that correlate with infrared flares detected by ground-based telescopes, illustrating how episodic accretion events, gas blobs spiraling inward, interact with these fields to produce observable twinkles, further confirming the black hole's mass at 4 million solar masses through orbital modeling of nearby stars, a cornerstone of contemporary astrophysics that underscores black holes' ubiquity. From stellar remnants to quasar powerhouses shaping galaxy evolution in the present day, easing backward into the chronicles of cosmic birth as serenity guides you gently, slowly through veils of antiquity, gently, slowly retracing the cataclysmic origins that forged these abyssal entities. We explore how black holes emerge from the death throes of massive stars, those luminous giants exhausting their nuclear fuel after millions of years and collapsing under their own weight in spectacular supernovae, a process first theorized in the 1930s by Subramanian Chandrasekhar and Robert Oppenheimer, where cores denser than neutron stars cross the threshold into singularity, with gravity overwhelming all other forces to form an event horizon, as evidenced by historical observations of remnants like Cygnus X-1 in the 1970s, the first confirmed stellar black hole via X-ray emissions from accreting companion star material, and extended to supermassive variants like Sagittarius A that likely grew from seed black holes in the early universe, perhaps direct collapse of pristine gas clouds, or mergers of smaller holes during the Rionization era around 13 billion years ago, with simulations informed by ESA NASA's Gaia data, suggesting initial masses of thousands of suns ballooning through accretion and hierarchical fusions amid the chaotic dawn of galaxy assembly, all rooted in the quantum fluctuations amplified post-Big Bang that clustered matter into the first proto-galaxies, setting the stage for these gravitational wells to anchor and regulate star formation over cosmic history. These formative tales, inscribed in the gravitational waves detected by LIGO since 2015 from distant mergers, help us gently, slowly honor the transformative deaths that populate the cosmos with these enigmas. Gently, slowly, like phoenix ashes coalescing into eternal shadows, where past supernovae not only birthed stellar black holes of 5 to 100 solar masses, but also enriched interstellar medium with heavy elements, fostering new generations of stars and planets, a cycle observed in archival Hubble images of supernova remnants that trace the evolutionary path leading to the stable supermassive hearts we probe now. Now projecting forward to the epochs awaiting, as calm overtakes you gently, slowly like the inexorable merge of orbital paths, gently, slowly anticipating the gravitational harmonies yet to resonate. We foresee how black holes will continue coalescing, with Sagittarius A potentially absorbing wandering stellar remnants, or merging with intruders from globular clusters over billions of years, while galaxy collisions, like the impending Milky Way Andromeda encounter in 4 billion years, promise supermassive unions that ripple space-time with detectable waves, as projected by NASA's Laser Interferometer Space Antenna mission, launching in the 2030s to capture low-frequency signals from such events, unveiling details of spin alignments and mass ratios that refine models of hierarchical growth, potentially culminating in a universe dotted with ultramassive black holes in isolated galaxy remnants as expansion dilutes encounters. Though rare inspirals could persist, emitting energy that subtly warms the cosmic background, guiding future observatories to map these fusions' demographics and test modified gravity theories in the far-flung tomorrows. In this eternal cycle of abyssal present, collapsed past, and merging future, allow black holes' profound gravity to draw your consciousness gently, slowly, into the event horizon of sleep, gently, slowly, where the universe's deepest secrets dissolve into dreamless peace. As the universe's deepest secrets dissolve into dreamless peace, emerging from those abyssal depths like faint stars piercing the veil of night, let us now meander through the present tapestry of dwarf galaxies, those diminutive cosmic jewels recently illuminated by the James Webb Space Telescope's infrared gaze, gently, slowly scattering their subtle light across the vast canvas of space, gently, slowly beckoning us to explore their clustered forms in regions like the galaxy cluster Abel 2744, where in 2025 the Uncover program, a collaborative effort between NASA, ESA, and CSA, identified 83 young low-mass starburst dwarf galaxies through deep field observations enhanced by gravitational lensing, a natural magnification from the cluster's massive gravity that bends light paths to reveal these hidden gems existing when the universe was merely 800 million years old. Their compact sizes, some with stellar masses as low as 2 million times that of our Sun, harboring intense bursts of star formation that produce copious ultraviolet radiation sufficient to ionize surrounding neutral hydrogen and contribute significantly to the cosmic ionization process, sensitive than prior studies, allowing astronomers to select 24 spectroscopic scrutiny with Webb's near-infrared spectrograph, uncovering how these galaxies' vigorous activity carves channels through interstellar gas, enabling ionizing photons to escape at rates around 25%, akin to modern analogs like green pea galaxies, all captured in the current era where such discoveries refine our view of the early universe's building blocks, populating the cosmic web with these understated yet pivotal players. In this contemporary mosaic, as your essence relaxes gently, slowly attuning to the gentle flicker of these distant luminaries, gently, slowly drifting like interstellar dust in their wake, imagine how Webb's 2025 data from the Sculptor Dwarf Galaxy, a nearby companion to our Milky Way, situated 290,000 light-years away in the constellation Sculptor, maps the intricate motions of its stars to probe the underlying dark matter distribution, revealing a spheroidal structure where ancient stellar populations orbit in elongated paths influenced by invisible halos, with the telescope's mid-infrared instrument capturing the galaxy's sparse gas content and low metallicity, elements heavier than helium comprising less than 1% of its mass, highlighting its role as a pristine relic in the local group, where ongoing observations integrate with Hubble's visible light views to create composite portraits that underscore dwarf galaxies' prevalence, numbering in the hundreds around larger hosts like ours. Their faint luminosities, often 1,000 times dimmer than the Milky Way, belied by their cumulative impact on galactic ecosystems, as evidenced by Webb's ability to resolve individual star-forming regions in analogs like Leo P, a isolated dwarf where 2025 imaging discloses patchy patterns of recent starbirth amid hydrogen clouds, triggered by internal dynamics rather than external interactions, offering a snapshot of self-regulated evolution in the present cosmic landscape, where these small systems serve as laboratories for understanding fundamental processes like feedback from supernovae that expel gas and regulate growth. These luminous vignettes, drawn from light that has journeyed across immense distances to grace our instruments now, encourage us to gently, slowly savor the understated elegance of these cosmic understudies. Gently, slowly, like whispers echoing in a grand hall, where the uncover findings emphasize how their escaped radiation accounts for the entirety of ultraviolet light needed to reionize the universe, transforming it from opaque to transparent and setting the stage for later structure formation, a narrative woven from spectra that detail emission lines from ionized oxygen and hydrogen, affirming their starburst nature in the here and now, gliding backward to the chronicles of cosmic coalescence as calm envelops you gently, slowly peeling away layers of eons like pages in an ancient tome, gently, slowly revisiting the tumultuous mergers that sculpted the galactic hierarchy. We reflect on how in the distant past, dwarf galaxies frequently collided and fused within the burgeoning cosmic web, a process beginning shortly after the Big Bang, when gravity drew together primordial overdensities into the first proto-galaxies, with simulations informed by ESA's 2025 refinements, suggesting that early dwarf systems, born from quantum fluctuations amplified during inflation, underwent hierarchical assembly through repeated interactions, where gravitational torques during close encounters stripped gas and triggered starbursts, as observed in fossil records like the ultra-diffuse galaxies today that bear scars of ancient cannibalism. particles in clusters where dwarfs are accreted onto giants, their stars redistributed into extended halos, while dark matter cores merge to form larger envelopes. An evolutionary pathway that built behemoths like the Milky Way through dozens of such events over 13 billion years, evidenced by stellar streams, trails of disrupted dwarfs, mapped by Gaia, illustrating how these Vajam not only enriched chemical compositions with heavier elements from supernova ejecta, but also shaped morphologies from irregular clumps to ordered spirals, embedding the history of violence within the serene structures we behold. These ancestral sagas, preserved in the fossilized kinematics of surviving remnants, permit us to gently, slowly acknowledge the foundational fusions that forged diversity. Gently, slowly, like rivers converging to carve majestic canyons, where past collisions dictated the survival rates of dwarfs, with many absorbed to fuel central black hole growth, a legacy that echoes in the metallicity gradients observed across galactic disks. Now extending our vision to the vistas of tomorrow, as repose claims you gently, slowly unfolding like the gradual weave of the cosmic filament, gently, slowly prophesying the architectures yet to emerge. We envision how dwarf galaxies will persist in influencing large-scale structures, integrating into the expanding web where dark energy drives clusters apart over trillions of years, with future missions like ESA's Euclid extending 2025 mappings to forecast the dilution of the cosmic skeleton, filaments, walls, and voids, where isolated dwarfs may endure as the last bastions of star formation in a cooling universe, potentially merging sporadically in local groups to form ultra-faint relics, as models predict a transition to a sparse, redshifted expanse where gravitational bound systems like our local group coalesce into mega-galaxies, while unbound dwarfs recede into invisibility, their contributions to reionization legacy informing simulations that probe alternative dark matter scenarios, guiding next-generation telescopes to unveil the ultimate configuration of voids dominating 90% of volume, a serene yet desolate harmony in the infinite ahead. In this boundless continuum of modest present, merged past, and structural future, let dwarf galaxies' subtle glow shepherd your mind gently, slowly toward the embrace of slumber, gently, slowly, where cosmic humility dissolves into profound rest, as profound rest envelops you in the subtle glow of those diminutive worlds, where humility echoes through the cosmic void like a fading whisper. Let us now attune our senses to the present cadence of neutron stars and pulsars, those compact remnants pulsing with rhythmic precision, illuminated by NASA's Chandra X-ray Observatory in its ongoing vigil, gently, slowly emitting beams of radiation that sweep across space like lighthouses in an endless sea. Gently, slowly captured in 2025, data releases that showcase over 100 newly identified pulsars through high-energy X-ray emissions, their rapid spins, some completing hundreds of rotations per second, betraying the extreme densities where a teaspoon of material weighs billions of tons, equivalent to cramming the mass of a mountain into a sugar cube, as affirmed by Chandra's advanced CCD imaging spectrometer that resolves the hot plasma surrounding these objects, revealing details of pulsar B150958 at the heart of a nebula stretching 150 light-years, where the neutron star's magnetic fields sculpt bizarre hand-like structures in the glowing gas, a phenomenon observed in exquisite detail this year, with Chandra's enhanced as your breath synchronizes gently, slowly with the steady beats of these celestial timekeepers, gently, slowly allowing your thoughts to pulse in harmony with their rotations. Envision how Chandra's 2025 observations of pulsar GX13+1, in collaboration with Japan's X-RISM mission, detect the cosmic wind from this neutron star, a rapidly spinning object only about 12 miles across, yet packing twice the sun's mass into that tiny volume. With X-ray spectra confirming surface temperatures exceeding 1,000,000 degrees Kelvin, where nuclear reactions forge exotic elements. And the mission's archival reanalysis, uncovering eccentric sources like ASCAP J1832 that challenge classifications by mimicking pulsar signals without the expected accretion from companions, all while affirming the canonical density of neutron star interiors, reaching up to 10 to the 14th times that of Earth's core, a crushing compactness where protons and electrons fuse into neutrons under gravity's unrelenting pressure. As detailed in Chandra's high-resolution maps that delineate the magnetic field lines twisting around these objects, powering jets that pierce through interstellar medium and influence surrounding star formation in the galactic neighborhoods we survey today, embodying the universe's efficient recyclers of stellar energy in their persistent glow. These radiant disclosures, harvested from X-rays that have traversed vast distances to reach our orbiting sentinel, beckon us to gently, slowly appreciate the resilient beacons that punctuate the present darkness, gently, slowly, like steadfast guardians illuminating hidden paths, where Chandra's detection of fractures in galactic bones, such as those in molecular clouds, struck by high-speed pulsars traveling at millions of miles per hour, illustrates how these neutron stars distort and energize their environments, with 2025 studies pinpointing the pulsar responsible for deforming a filamentary structure through its supersonic passage, further highlighting their role in dispersing heavy elements across space, a dynamic interplay captured in the observatory's quarter-century legacy that continues to refine our grasp of these objects' magnetic dynamos, generating fields trillions of times stronger than Earth's, sustaining the pulsations we detect across the electromagnetic spectrum in this era, shifting our murmur to the echoes of stellar lifetimes past, as tranquility draws you gently, slowly back through the annals of astral evolution, gently, slowly unfolding the narrative of stars' grand cycles that culminate in these dense airs. We revisit how massive stars, 8 to 20 times our sun's mass, exhaust their fusion fuels over millions of years, progressing from hydrogen to helium, carbon and iron in layered cores, until the inert iron heart triggers catastrophic collapse, a sequence first outlined in the mid-20th century through computational models that predicted the supernova explosions expelling outer envelopes while compressing the core into a neutron star, as evidenced by historical observations of remnants like the Crab Nebula from the 1054 supernova, where the central pulsar spins 30 times per second, its discovery in 1968 confirming the theoretical endpoint of stellar evolution, where gravity overcomes neutron degeneracy pressure only for black holes and even heavier progenitors, with ESA's integral and XMM Newton missions in prior decades, complementing Chandra by mapping gamma ray bursts linked to these births, illustrating how the past's violent detonations seeded the cosmos with elements beyond iron, gold, platinum, forged in the neutron-rich ejecta legacy that underpins the chemical diversity enabling planetary systems and life across galactic history. These ancestral rhythms, encoded in the relic radiation and supernova remnants scattered through time, enable us to gently, slowly revere the transformative journeys that birthed these compact wonders. Gently, slowly, like ancient forges, cooling into enduring artifacts, where the stellar life cycle's phases, main sequence stability, red giant expansion, and core collapse, dictate the formation of neutron stars in isolation or binaries, with past mergers in dense clusters accelerating spins to millisecond rates. A process observed in globular cluster surveys that trace the evolutionary tree back to the universe's first generations of massive stars igniting shortly after the Big Bang, shaping the metallic buildup we inherit today. Now extending our vision to the futures yet to pulse, as serenity enfolds you gently, slowly, like the gradual spin down of aging beacons, gently, slowly foretelling the cataclysms and evolutions ahead. We anticipate how neutron stars will continue their gradual deceleration over billions of years, losing rotational energy through magnetic dipole radiation until some accrete matter from companions to reignite as recycled pulsars, while others in close binaries merge to unleash short gamma-ray bursts detectable by future observatories like ESA's Athena, launching in the 2030s to map X-ray afterglows with greater sensitivity, potentially culminating in black hole formation if masses exceed the Tolman-Oppenheimer-Volkoff limit around 3 solar masses, with models predicting increased supernova rates in star-forming regions as the universe's metal content rises, birthing more neutron stars that could pair up for gravitational wave events sensed by advanced LIGO upgrades, weaving a tapestry where these objects evolve into quiet, cold spheres in the far cosmic chill, their final fates intertwined with the expanding void's isolation, whispering of enduring cycles in the eons to unfold. In this harmonious blend of pulsating present, cyclic past, and prophetic future, permit neutron stars' rhythmic whispers to guide your awareness gently, slowly into the depths of repose, gently, slowly where the universe's dense mysteries fade into serene oblivion. As the universe's dense mysteries fade into serene oblivion, leaving only the soft afterglow of those rhythmic beacons to linger in your mind's quiet expanse. Let us now wander into the present realm of exoplanets, those distant worlds orbiting stars beyond our sun, unveiled through the preparatory insights of ESA's Ariel mission, gently, slowly orbiting in conceptual orbits as we await its 2029 launch, gently, slowly drawing from 2025 preliminary data that hints at biosignatures on 3 promising candidates, ethereal traces like methane and oxygen imbalances in their atmospheres that suggest potential life processes, as analyzed in early spectroscopic simulations and ground-based validations by ESA teams, where Ariel's designed infrared capabilities are tested against current datasets to prioritize targets among the over 10,000 exoplanets confirmed by NASA's James Webb Space Telescope this year, including 50 with detectable water vapor in their gaseous envelopes. Worlds like the temperate super-Earth LHS 1140b, where hydration cycles evoke misty veils around rocky cores, all captured in the ongoing census that catalogs these planets' sizes, masses, and orbital dances through transit photometry and radial velocity methods, offering a contemporary map of diverse systems ranging from scorching hot Jupiters to icy rogue wanderers adrift in interstellar space. A revelation that enriches our understanding of planetary formation in the galaxy we navigate today. In this unfolding panorama of alien horizons, as your relaxation flows gently, slowly aligning with the gentle tug of these far-off gravitational bonds, gently, slowly envisioning clouds parting to reveal hidden skies. Consider how Ariel's 2025 precursor studies, integrating data from Webb's mid-infrared instrument, have spotlighted exoplanets such as TRAPPIST-1, E, F, and G, 3 of the 7 rocky siblings around a cool red dwarf, where atmospheric models predict water vapor layers thick enough to harbor liquid oceans beneath, with biosignature detections and simulated spectra showing ozone asymmetries that could stem from biological activity, a finding that refines target selection for Ariel's future surveys of 1,000 exoplanets, focusing on their chemical compositions to discern habitable zones where temperatures allow liquid water, as ESA's collaborative analyses with NASA affirm the prevalence of water-world hybrids among the 10,000 plus tally, many exhibiting hydrogen-helium envelopes pierced by heavier molecules like carbon dioxide and ammonia, all observed in real time through space-based platforms that filter starlight dimmed by planetary passages, painting a vivid portrait of a universe teeming with potential abodes in this era of discovery, where each new confirmation expands the cosmic family tree, with the siblings unlike our own Earth, yet echoing familiar elemental symphonies. These emergent visions, born on light from stellar systems, light years distant, invite us to gently, slowly cherish the multiplicity of worlds shaping our current cosmic narrative, gently, slowly, like scattered seeds germinating in fertile voids, where the 2025 biosignature hints on those 3 exoplanets, provisional names like Ariel Prelim 1, 2, and 3 in internal reports, emerge from machine learning algorithms processing noisy data to isolate organic signals, complementing Webb's direct imaging of protoplanetary disks that nurture these planets' births, underscoring the diversity from gas giants to terrestrial analogs in the here and now, a diversity that Ariel's tiered spectrometer will one day dissect with precision across visible to infrared wavelengths, revealing the atmospheric stories that whisper of geological and perhaps biological wonders across the galactic plane, drifting rearward to the foundations of exoplanet exploration. As peace carries you gently, slowly through the mists of astronomical heritage, gently, slowly retracing the luminous trails blazed by NASA's Kepler mission, we connect these modern marvels to the groundbreaking discoveries of the early 2010s, when Kepler's unblinking stare at a patch of sky in Cygnus and Lyra detected over 2,600 exoplanets through the transit method, observing periodic dips in starlight as planets crossed their hosts' faces, a technique that revolutionized our view by confirming the ubiquity of planetary systems, with finds like Kepler 4.2b, an Earth-like world in a habitable zone around a sun-like star, sparking imaginations of distant oceans and atmospheres, all rooted in the spacecraft's 4-year primary mission that cataloged candidates later verified by ground telescopes, revealing statistical insights into planet occurrence rates, showing rocky worlds common around red dwarfs and gas giants, rarer in tight orbits, a legacy built on earlier hints from radial velocity surveys in the 1990s that first spotted 51 Pegasi b, the inaugural hot Jupiter, setting the stage for Kepler's population studies that informed models of disk instability and core accretion in protoplanetary nebulae. Echoes of the solar system's own formation 4.5 billion years ago from a swirling cloud of gas and dust. A historical tapestry that wove the threads for today's expansive archive. These venerable chronicles, preserved in the archived light curves and velocity wobbles from yesteryear, allow us to gently, slowly venerate the pioneering voyages that unveiled these hidden companions. Gently, slowly, like ancient maps charting unexplored seas, where Kepler's extended K2 phase in the 2010s added thousands more across the ecliptic plane, highlighting multi-planet systems with resonant orbits that hint at migratory histories driven by gravitational interactions, a foundational knowledge that bridges the exploratory past with the detailed characterizations we pursue now, enriching the quest for understanding planetary diversity through time. Now gazing toward the uncharted tomorrows as slumber beckons you gently, slowly like the slow orbit of a distant moon rising, gently, slowly anticipating the revelations that life-seeking endeavors will bring. We foresee how Ariel's full deployment in 2029 will catalyze the hunt for biosignatures on hundreds of exoplanets, employing transmission spectroscopy to parse atmospheric transits for markers like phosphine or dimethyl sulfide that could indicate microbial life, with follow-on missions like NASA's Habitable Worlds Observatory in the 2040s, aiming to directly image Earth analogs and spectroscopically confirm oxygen-rich biospheres, potentially discovering dozens of habitable candidates where liquid water and stable climates foster complexity. As predictive models from 2025 suggest a statistical likelihood of detecting life signs within the next decade through enhanced signal-to-noise ratios and machine-assisted anomaly detection, leading to a paradigm where exobiology transitions from speculation to science, unraveling whether we are alone in a universe that may bloom with biospheres or remain a solitary echo. A future horizon where these whispers of possibility evolve into confirmed symphonies of existence across the cosmic stage, in this expansive arc of worldly present, pioneering past, and life-hunting future. Let exoplanets' distant calls lure your spirit gently, slowly into the tranquil void of sleep, gently, slowly, where the universe's potential abodes merge with your dreams in harmonious quietude, as harmonious quietude settles deeper within you, where the calls of distant worlds blend seamlessly with the universe's ancient hymn. Let us now attune ourselves to the present glow of the cosmic microwave background, that faint radiation permeating every corner of space, meticulously mapped by ESA's Planck mission. Through its final data releases, gently, slowly unveiling a uniform sea of microwaves cooled to just 2.7 degrees above absolute zero, gently, slowly offering a snapshot of the universe's thermal equilibrium as observed in contemporary analyses that integrate polarization and temperature data to refine cosmological parameters with exquisite detail, as evidenced in the 2018 legacy products, revisited in 2025, collaborative studies with ground-based telescopes like the Atacama Cosmology Telescope, where the CMB's subtle anisotropies, its tiny temperature variations of 1 part in 100,000, reveal the seeds of galaxy formation imprinted on this relic light, a pervasive echo that bathes our instruments today in a consistent spectrum, peaking at 160 gigahertz, captured through Planck's dual instruments that scanned the sky over 4 years to produce all-sky maps of unprecedented clarity, allowing astronomers to discern the universe's geometry as flat within measurement precision, a reality affirmed in recent cross-validations that underscore the CMB's role as the ultimate backdrop against which modern cosmic structures unfold in the here and now. In this enduring radiance of the present, as your mind wanders gently, slowly through this thermal veil, like a voyager in an endless mist, gently, slowly, feeling the warmth of ancient photons caressing your thoughts, contemplate how Planck's 2025 refined datasets, combining with new Atacama observations from March and November releases, provide sharper polarization maps that trace the E-mode and B-mode signals, indicators of early plasma oscillations and potential gravitational waves, with the mission's high-frequency instrument resolving frequencies up to 857 gigahertz to filter foreground dust and synchrotron emissions from our galaxy, thereby isolating the pristine CMB signal that confirms the universe's composition, about 5% ordinary matter, 26% dark matter, and 69% dark energy, a breakdown honed through angular power spectra analyses that quantify fluctuation scales from large cosmic voids to small cluster precursors, all in the current epoch where these measurements resolve tensions with local Hubble constant estimates by favoring a value around 67 kilometers per second per megaparsec, offering a cohesive picture of a universe whose light from this background has stretched over billions of years to reach us, embodying the thermal afterglow that defines our observational horizon today. These pervasive signals, collected from every direction in the sky to form a complete panorama, encourage us to gently, slowly immerse in the homogeneous whisper that envelops the cosmos now, gently, slowly, like a soft blanket of light draping over all existence, where the 2025 integrations of Planck data with Atacama's high-definition images enhance resolution to capture finer details of the CMB's temperature dipole, caused by our motion relative to the rest frame at 370 kilometers per second, further calibrating the universe's expansion history and affirming its isotropy on large scales, a testament to the mission's legacy in providing baseline maps that contemporary projects build upon to probe subtle effects like the integrated Sachs-Wolf effect, where gravitational potentials alter photon energies en route, all illuminating the dynamic yet balanced state of the universe in this moment, turning our soft reflection to the remnants of primordial times as repose guides you gently, slowly backward through the eons, like retracing a fading trail of stardust, gently, slowly unveiling the origins embedded in this radiant fossil. We connect these present observations to the Big Bang's afterglow, formed when the universe cooled sufficiently around 380,000 years after its inception for electrons and protons to combine into neutral hydrogen atoms, releasing the trapped photons in a process called recombination that transformed the opaque plasma into a transparent expanse, a transition first predicted in the mid-20th century and confirmed through Planck's spectra that match a near-perfect black body curve with tiny deviations encoding quantum fluctuations from the inflationary epoch mere fractions of a second post-Big Bang, where rapid expansion smoothed the cosmos while amplifying these seeds into the density variations that gravity later amplified into galaxies. As detailed in a precise constraints that peg the spectral index at slightly less than 1, indicating scale invariant perturbations rooted in the universe's hottest, densest phase. A narrative of emergence from singularity that the CMB preserves as the oldest observable light, stretching its original high-energy wavelengths into microwaves through cosmic expansion over 13.8 billion years. These primordial imprints, stretched across the observable universe to span 46 billion light-years in radius, help us gently, slowly honor the foundational burst that echoes through all subsequent evolution, gently, slowly, like the initial ripple in a vast pond propagating outward, where the Big Bang's energy release not only birthed space, time, and matter, but also set the initial conditions for baryogenesis and nucleosynthesis, producing the light elements observed today. A history that Planck's data deciphers by measuring the acoustic peaks in the power spectrum, oscillations from sound waves in the early plasma that encode the baryon to photon ratio and affirm the Standard Model's triumph in describing the universe's infancy, bridging the theoretical constructs of the past with the empirical validations we cherish now, envisioning the prospects on the cosmic horizon as tranquility propels you gently, slowly forward into uncharted expanses, like a comet charting new paths, gently, slowly anticipating the clarifications that advanced scrutiny will yield. We foresee how future missions will eclipse Planck's precision, with endeavors like Japan's Lightbird satellite, planned for launch in the late 2020s, aiming to detect primordial B-mode polarization from inflationary gravitational waves at sensitivities 10 times finer, complemented by ground-based arrays such as the CMB Stage 4 experiment that will map the microwave sky with millions of detectors to resolve smaller angular scales and mitigate systematic errors, potentially refining the universe's age estimate beyond the current 13.8 billion years, with errors reduced to mere millions of years through multi-frequency observations that better subtract galactic foregrounds, all while probing neutrino masses and dark energy dynamics in greater detail, leading to an era where these enhanced whispers might reconcile cosmological tensions and unveil new physics, such as axion-like particles or modified gravity. In the distant tomorrows, where the CMB's secrets continue to unfold with ever sharper fidelity, in this timeless resonance of background present, echoing past and probing future, allow the cosmic microwave's gentle hum to usher your essence gently, slowly toward the serenity of profound sleep, gently, slowly, where the universe's oldest light cradles you in eternal calm. As eternal calm cradles you in the oldest light's embrace, where the microwave hum fades into an even vaster symphony of possibilities. Let us now contemplate the present concept of the multiverse, that theoretical expanse of countless realities branching from our own, drawn from contemporary inflation models, refined by ESA's Planck mission data, and NASA's theoretical cosmology groups. In 2025, gently, slowly suggesting a cosmos where our universe is but one bubble in an infinite foam of parallel existences, gently, slowly emerging from the rapid expansion phase known as cosmic inflation that smoothed the observable universe while birthing myriad others through variations in physical laws, as posited in models where the inflatant field, a scalar energy driving that exponential tangential stretch, fluctuates to create pockets with differing constants like gravity's strength or particle masses, all supported by Planck's legacy analyses that in recent cross-checks with ground-based observatories affirm the flat geometry and scale invariant perturbations consistent with eternal inflation scenarios, where our patch appears fine-tuned for life, yet coexists with infinities of uninhabitable voids. A perspective echoed in NASA's 2025 white papers on quantum cosmology that integrate string theory's multidimensional frameworks to propose these bubbles as separate domains in a higher dimensional landscape, offering a contemporary lens on existence where the multiverse resolves anthropic questions by positing that we inhabit one of many viable realms in this grand unfolding tapestry observed through indirect evidence like the CMB's uniformity today. In this modern mosaic of theoretical wonders, as your serenity deepens gently, slowly sinking with the subtle divergences of these cosmic branches, gently, slowly allowing your imagination to wander across invisible thresholds. Envision how 2025 collaborations between ESA theorists and NASA's Goddard Space Flight Center have bolstered the inflationary multiverse through simulations that model how quantum effects during inflation generate a fractal-like structure of universes, each isolated by horizons beyond our light cone. With Planck's refined polarization data from its 2018 maps, reanalyzed this year, revealing tensor to scalar ratios below 0.01 that hint at simple inflaton potentials capable of eternal self-reproduction, leading to an ever-expanding ensemble where bubbles nucleate endlessly, a concept that aligns with string theory's landscape of 10 to the 500 vacua, stable energy minima, where different physical laws prevail, as explored in recent papers that use machine learning to navigate this vast parameter space, providing a snapshot of a reality where our universe's parameters, such as the electron's mass or the fine structure constant, are not unique but selected from a probabilistic distribution, all in the current theoretical frontier that bridges quantum mechanics and general relativity to paint a picture of multiplicity pervading the cosmos we ponder now, embodying the universe's capacity for boundless variation in its elegant, interconnected whole. These conceptual horizons, illuminated by the interplay of data and theory in the present day, invite us to gently, slowly embrace the idea of infinities nestled within the finite, gently, slowly, like hidden gardens blooming in parallel realms, where the multiverse's framework, bolstered by 2025 ESA reports on cosmic variance limits, underscores how our observations might sample just one iteration in an ensemble, with inflationary models predicting observable signatures like negative spatial curvature in rare patches, though ours appears flat, or subtle CMB anomalies that ongoing surveys probe, further integrating with NASA's James Webb insights on early galaxy distributions that test inflation's predictions without contradiction, all weaving a narrative of diversity that enriches our understanding of why the cosmos appears as it does in this epic of exploration, easing our whisper back to the quantum whispers of the universe's dawn as tranquility envelops you gently, slowly unraveling the seeds sown in primordial chaos, gently, slowly retracing the fluctuations that sparked this multiplicity. We delve into how quantum fluctuations in the inflaton field during the inflationary epoch, a mere 10 to the minus 32 seconds after the Big Bang, these random jitters inherent to quantum mechanics stretched across the inflating space to create density contrasts that later condensed into galaxies. But in eternal inflation models, regions where inflation ends differently, birth separate universes with unique properties, a historical foundation rooted in the quantum gravity puzzles of the early 20th century, when Heisenberg's principle introduced inherent unpredictability, evolving through the 1970s quantum field theory advancements that applied to cosmology, leading to the standard inflationary paradigm by the 1990s, where Planck scale energies allowed for such multiversal branching, as evidenced by CMB maps from COBE in 1992 that first detected those amplified fluctuations, setting the stage for precise measurements by WMAP and Planck that confirmed their Gaussian, nearly scale-invariant nature. A legacy of quantum origins that explains the large-scale homogeneity while permitting the diversity of a multiverse, all tied to the Big Bang's quantum foam, where possibilities proliferated into the structured reality we trace back through time. These foundational quanta, echoed in the relic radiation that has journeyed from the universe's infancy, enable us to gently, slowly revere the probabilistic cradle that birthed endless branches. Gently, slowly, like ripples from a single pebble, spawning divergent streams, where the past's inflationary dynamics, driven by a slow-rolling scalar field, ensured that quantum noise not only seeded our cosmic web, but also perpetuated inflation elsewhere, creating an eternal process that historical models have refined to accommodate string theory's extra dimensions, bridging the quantum past with the expansive present we inhabit, now projecting our gaze to the futures awaiting discovery as peace draws you gently, slowly forward like a leaf on an infinite river, gently, slowly foreseeing the validations that theoretical pursuits may yield. We anticipate how string theory tests advance through 2025 initiatives like CERN's high luminosity upgrades and proposed space-based interferometers could probe the multiverse indirectly by detecting extra dimensions or supersymmetric particles at energies up to 14 tera-electron volts, with models suggesting that collider signatures or gravitational wave echoes from bubble collisions, rare events where adjacent universes brush horizons, might emerge in detectors like LIGO's successors, while ESA's Euclid and NASA's Roman telescopes extend 2025 mappings to search for CMB patterns like domain walls or curvature anomalies that hint at neighboring realms, potentially confirming the string landscape's vast array of vacua through precision cosmology, leading to an era where quantum entanglement experiments or holographic principles test multiversal connectivity, unraveling whether our reality is one of many in a unified theory that encompasses all possibilities. A horizon where these whispers of multiplicity evolve into empirical harmonies in the boundless tomorrows. In this infinite weave of multiversal present, fluctuating past, and testing future, permit the branching cosmos to carry your consciousness gently, slowly into the vastness of repose, gently, slowly, where the universe's myriad secrets dissolve into tranquil unity. As tranquil unity envelops you in the branching cosmos's gentle hold, where myriad secrets merge into a singular peace that spans all realities. Let us now deepen this repose by drifting further into the present serenity of the universe's vast embrace, imagining yourself as a weightless particle suspended in the cosmic web Euclid that map the steady flow of dark energy weaving through the void today, inviting you to surrender completely to this floating freedom. Your body heavy yet buoyant, like a comet's tail trailing in the solar wind, as every muscle unwinds in waves of profound ease that echo the rhythmic pulsations of distant quasars lighting the night sky now. In this moment of absolute surrender, as your breath flows gently, slowly in sync with the universe's subtle breath, the inflow and outflow of cosmic radiation, bathing all existence, gently, slowly feel your mind emptying like the vast intergalactic voids that dominate 90% of space in our present cosmos, gently, slowly letting go of the day's remnants as if they were fleeting asteroids passing harmlessly by, recalling how in the past the universe's early chaos gave way to this ordered tranquility, through the cooling after the Big Bang, where primordial energies settled into the stable structures we float among today, and looking ahead to the future where this peace will endure in an ever-expanding quietude, stars winking out one by one into a serene, starless night, trillions of years hence. Yet for now, in this eternal present, permit your awareness to sink deeper, your eyelids impossibly heavy, your limbs limp and at rest, cradled by the invisible arms of gravity that hold planets in their orbits with unwavering grace, a gravitational harmony documented in ESA's 2025 Gaia updates that trace the Milky Way's gentle sway, allowing you to release any lingering tension into the abyss, where it dissipates like cosmic dust scattering in the solar breeze. Now, envision yourself adrift in this cosmic ocean, gently, slowly buoyed by waves of dark matter that invisibly support the galactic frameworks around us, gently, slowly inhaling the calm of infinite space that fills your lungs with pure relaxation, gently, slowly exhaling any whispers of worry into the void where they vanish among the redshifted galaxies receding in the current expansion, drawing from the historical formation of these invisible scaffolds in the universe's youth that shaped the peaceful vastness we inhabit, and anticipating the future dilution where this serenity stretches into boundless isolation. Yet here, in the tranquil now, let your heart rate slow to match the languid turn of spiral arms in distant galaxies, your thoughts fading like the afterglow of ancient supernova, dissolving into nothingness as sleep's gentle pull draws you under, your entire essence merging with the universe's profound, unending quiet, ready to embrace the restorative depths that await in dreamless slumber. As your entire essence merges with the universe's profound, unending quiet, ready to embrace the restorative depths that await in dreamless slumber, let this final whisper guide you even deeper into the cosmic fold, where the present vastness of space envelops you like a soft, infinite blanket woven from the threads of interstellar dust and dark matter halos, gently, slowly drawing you into complete surrender, gently, slowly allowing every remnant of awareness to fade like the dimming light of a distant quasar observed by NASA's Chandra in its 2025 surveys, its glow persisting across billions of light years in the serene equilibrium of the cosmos today, inviting you to release fully into this tranquil void, your body and mind dissolving into the gentle curvature of space-time that cradles all existence with effortless poise, as if floating amid the cosmic filaments mapped by ESA's Euclid mission this year, their intricate web holding galaxies in a balanced dance shallower gently, slowly aligning with the subtle expansion of the universe itself. The steady stretch measured at 73 kilometers per second per megaparsec in recent Hubble and Euclid integrations. Gently, slowly feel the weight of the day evaporating into the ether, like primordial gases coalescing in the past's early epochs, where the Big Bang's initial burst, 13.8 billion years ago, forged the elements now drifting peacefully through space. A historical symphony of creation that transitioned from fiery chaos to the cool, expansive calm you sink into now, and peering toward the future where this dilation will carry on into a colder, more isolated serenity over trillions of years. With stars gradually extinguishing in a heat death predicted by thermodynamic models from NASA's 2025 cosmological projections. Yet in this eternal now, permit your thoughts to scatter like cosmic rays traversing the void, your heart sinking with the quiet pulse of neutron stars spinning in distant remnants, their densities confirmed through Chandra's latest X-ray visions as 10 to the 14th times Earth's core, allowing you to let go utterly, your consciousness blurring into the boundless night. Now, as the whisper grows fainter, gently, slowly enveloping you in the universe's tender hug, like the gravitational embrace of dark energy dominating 68% of all content in current observations. Gently, slowly releasing you into oblivion's arms. Gently, slowly recalling how quantum fluctuations in the inflationary past seeded this vast harmony, amplifying into the structures that will evolve into isolated islands in the accelerating future. Yet here, in the dissolving present, feel yourself becoming one with the cosmic whole, your form melting away like ice in a warming nebula, thoughts evaporating into pure stillness, breaths slowing to near silence, the universe's secret